Okay, so for this problem, we have two questions. Okay, what type of signal does the circuit in figure 67 produce? So that's the circuit, the figure that you can see here. Determine the frequency of the output and show how to change the frequency of oscillation in the same figure to 10 kilohertz. Okay, so this is a triangular wave oscillator. Okay, so let's write that down. So triangular wave oscillator. Okay, and for the triangular wave oscillator, you can actually have two outputs. So the first output is somewhere here. Okay, so this output will give you a square wave. Okay, for this output right here, we have a triangular wave. It's also called a sawtooth wave. Okay, and the output of that is given by this expression, plus or minus Vmax times R3 over R2, where R3 are these two resistors here, R3 and R2. So these define the amplitude of the output voltage, depending on what the value of Vmax is. And since we don't know what Vmax is, then we just simply have this expression for Vmax. We do Vout. We do know what R3 and R2 are, so that's 18 kilo ohms and divided by 56 kilo ohms. So we know at least that the output voltage is given by 0.32 times Vmax. Okay. Now for the frequency. The frequency, okay, is solved using this equation. 1 over 4 R1C times R2 over R3. So if we plug all that we know inside this equation, we have 4 times R1, which is 22 kilo ohms, times C, which is 0.022 microfarad, times 56 kilo ohms divided by 18 kilo ohms. Okay, so this gives us a frequency of 1.6 kilohertz. Okay, and we see that the frequency is actually defined by R1. What the role of R2 and R3 are to control the output voltages. So if we want to change the frequency from 1.6 kilohertz to 10 kilohertz, as indicated in the problem, then what we need to change is, or what will happen is that we need to change R1. Okay, so in this case, we can write R1 is equal to 1 over 4 times 10 kilohertz, okay, times 0.022 microfarad times 56 kilo ohms divided by 18 kilo ohms. So this means that R1, okay, will give us, okay, so this will give us 35 kilo ohms. 35 kilo ohms. Okay, but we don't have 35 kilo ohms available in stores, so we use what's available, what you can buy in store. That's a 36 kilo ohm. Okay, there may be something wrong here, because if the frequency increased by 6-7 times, then R1, according to this equation, if F increases by 6-7 times, then R1 should decrease by 6 or 7 times as well. So there must be something wrong with how I calculated this. Maybe in how I plug this in the calculator. So we expect R1 to be 6 or 7 times smaller than 1.6 than 22 kilo ohms. So maybe this is 3.5, not 35. So 3.5 kilo ohms. Okay, or we use instead 3.6 kilo ohms. This is the one that you can buy in store. Okay, so yeah, you can check the answer if this is correct.